Hey, what's up everybody? Today we're going to look at a UPS, a 30 kilowatt UPS. Look at this beast. This is a size comparison. Here we got the UPS. Quite large actually. I found this at the dumpster. And I couldn't take it that day I found it, so I told them to not scrap it. That's why they have written on the top there, skrotas ej. That means not to be scrapped. And I was there 2 days later with my friend and picked it up, because this thing weighs a bloody ton. I measured how much it weighed and it was around 90 kilograms, so that's very much. It's a SUVT PM 30kh. If you want to Google it. Here you can see some information. You don't got anything else, you just got that little label. Here you can see the connectors. You can look inside of them. This tube looks pretty similar. Some earth pins in the middle here. A communication port. Same thing with this side. But this one don't have any communication port. I think these things are pretty expensive. Not the cheapest things. Especially when it's a APC. So just before we take it apart, let's take some measurements of it. 42 centimeters wide. 50.5 centimeters high. 61 centimeters deep. That's a pretty large UPS. I'm still surprised that I could get it up here. So now I have removed the screws. So let's see if I can remove this. Oh yes, look at that. The whole piece came off. So now we can see some great stuff in here. Got 3 converter boards. Here you can see this is the battery and power intake. Also battery and power intake. So we got power or battery here. We got the power coming in. And we got 1 output on the top and 1 output on the bottom. So these are 2 parallel lines that coming out. Those 3 fans blows air on the heat sinks in here. Those 3 fans should blow air through a similar heat sink on the other side. So if you look carefully in there, we can see there's 3 similar boards in there as well. So there is no large IGBT bricks in this one. Now I have removed some screws and removed the plate which was here. And remove some screws on the circuit boards on the top. Now I can see that there's actually 2 modules in here. Got one here, which can be separated from that one. This one is much bigger. So this is actually optional if you want to buy this converter without this module here. But this one has this module and have more power. Or twice as much power, and you get actually a parallel line out of it. That's very nice. We got this board that connects the 2 modules together. It's nothing special, just like a big jumper wire. Now let's see if we can get this board out. And you can see all the processors and stuff. Logic controls, And we got this little accessory board that connects to Ethernet. That's very nice. You can actually use this on almost all the UPSs that has this accessory hub. Before we take it more apart, you can see that nothing is actually connected to the case. We got these plastic standoffs. So these modules are actually or physically insulated from the metal frame. Yes, I removed the bus bars completely. And now it was much easier to remove it. That's heavy stuff. Yes, a pretty similar converter on the back. Bend this back a little bit. Here we go. Look at that. That's some nice connections. I'm going to remove this converter in the middle here. We got two screws here and screws on the other side. Oh no, we don't got any screws on the other side. You just pull them like this. And yes, here we go. They're pretty heavy. There are some heavy stuff. Two huge heat sinks. Got two chokes in there, two other chokes here. We got transistors and diodes. A lot of diodes there. That's another thing why you don't want this chassis to be grounded. That's because we got these heat sinks directly mounted on this frame here, so you don't want to earth that one if something goes wrong. Yes, converters removed, and here you can see those standoffs made out of plastic. We're gonna have a look on those power modules later, but now I want to dismantle this first. I'm going to remove the back plate and all the connectors, so we can remove that part here. Well, now that one is off, and let's remove the module. Yes, I removed some more screws. I removed this insulator or standoff that just fell off. Yes, I removed the standoff, which were here, so I'm gonna keep that. Maybe it can be used for something. And here we got the power supply. I think it runs on 2 phases. We got 2 fuses over there. Yes, we got these connectors. They're connecting to that one, which just fell down. And this one is still up here. They connect into those ones. And I think this wire here was from this power supply to the board which was here, or the module which sat right here. And now I have unscrewed this last module. This had screws on the bottom here and on the side. So the module is here. Here you can see the standoffs, insulators. You see, like this one. It's a metal part here. We got screws. We got a plastic plate. And here we got another plastic plate just in there. A bit of plastic. So this part here does not have any contact with this outer case. Same with those on the bottom. So now most of the unnecessary stuff is removed. So I removed all the screws and the fuses. is just to lift this circuit board up. It's pretty big, lot of components on it. And here you can see the 3 converters, one for each phase. So I'm going to remove some of this and take away these converters and see what we got. And now all the 3 converter units are removed, and we just got this bypass stuff and contactors left. So here we got the circuit board. Got some current transformers, some filters, relays, and a ton of fuses. So this contactor had these bus bars that connected the 2 modules together. Here are the trigger wires, or the gate wires. And we got a toroidal transformer here as well. So I'm going to unscrew these IGBTs and the whole circuit board should pop off. So the screws and connectors are disconnected, the screws removed. And there are the IGBTs. So screws are taken away, and it's pretty nice heat sinks. Let's see what these things are. Yes, look at that. They are not IGBTs. They are SCRs. 3 SCRs. Wonder how large coil gun I can build with this. And here's everything I scored from the UPS. Here are the converters, 6 of these. I took that one apart so you can have a look at it. You got the circuit boards here, which are controlling those ones. The microcontroller board, some contactors, fuses, bypass, and some fans. Let's begin with the brains of this UPS. The main board, everything is happening here. We have 2 main processing chips, FPGA, some memory. There are not so much interesting stuff on this. So let's go to the converter module boards instead. So here's the power module from one of the converter modules. So you can see that that's a lot of power components. These are the transistors. Have these heat sinks. Got 9 capacitors that are rated 10 microfarad, 600 volts DC. And here are some larger capacitors, electrolytics. So I just flipped the board around. You can see there is a bunch of SMD components. And here's the other board. There are less components on this one. Yes, again I flipped it around. And I think that these are the bleed resistors for the capacitors. Here we got the main power input board. So the power is supposed to come into this board immediately after the connectors on the back of the UPS. The contactors are supposed to be here. These are the connections that goes to the contactor. And all of these clips here, it should go cables here from the connector. We got 3 current transformers. So the bus bar is connected directly to these screw terminals. Got filter capacitors. We got some protection here. And more capacitors. This connector is supposed to go to the power supply. and there are a lot of 250 milliamp fuses, fast fuses. We got 2 relays, 12 volt, 3 amps, and we got a bodged power resistor here, some bodge wires. So there you can see that I just put a power resistors across those components there. And the resistor is a 5 watt 270 ohm. And here we got the power supply board. And actually I don't know where the primary side or the secondary side is, because nothing is isolated in here. We don't have any power capacitors. We just got these low voltage capacitors everywhere, 35 volts, 1500 microfarads each. And on this side we got a lot of small SMD components and a 35 volts, 100 I think, no, 330 microfarads. We got 2 fuses here, and I think these are some big transistors. I think they are transistors. Yes, there are transistors here. And same with this one here. I don't know what. I think it's a some kind of buck converter unit. Like you just put 24 volts into it and it gives you like 12 volts, 5 volts, 3.3 volts, and so on. So I think it's more like a kind of that type of switch mode power supply, but you don't got like 230 volts or 400 volts going into this, because we don't got any rectifier, we don't got any power components less than these transistors here. Nothing that's rated over 35 volts. Everything is 35 volts here, like this, all these capacitors. I thought you could connect it here, that this was the primary coming in, like 400 volts. But no, it goes to this capacitor, which is like 35 volts and no rectifier and nothing. So I think it's some kind of buck converter. If you lift it up and look underneath it, as you can see, no insulation anywhere. Flex goes from this side of the transformer to the other side of the transformer. And if you look at the transformer, you can see pretty thick wires there, and on the other side pretty thick wires there as well. So obviously some kind of a buck converter. And here is one of the power converter modules with the heat sinks. As you can see, we can't see so much. Here are the transistors and diodes. And exactly the same thing on the other side. And here's how it looks like without the heat sinks. And inside here we can see we got 4 capacitors. We got the small boards, which are the gate drivers, and the chokes for DC and the AC side. Current transformers, 3 of them. This one here, this is shielded from the coils here. And these are not actually current transformers, they are current monitoring devices. They got these Hall sensors instead of the traditional coil, so they can actually measure DC. And here's a little close-up on the gate drivers. And here we got our last board, which is the bypass. The SCRs are coming here. We got this snubber circuit, a toroidal transformer, The toroidal transformer should be connected right here. That is connector that goes to the main board. And here are some small gate drive transformers. If we flip this over, you can see here they are bridged two SCRs together. They are arranged like this. So by connecting them, bridging these two together, they will form a triac, and that will conduct AC, and SCR just conducts DC. I think I found the problem. You see a burn mark here, and this is a miscoloration going like around here, around some components here. So I think the gate driver for one SCR didn't work. The bypass was faulty. I wonder how bad the sine wave looked like when one SCR didn't turn on. The electronics which were connected to this UPS obviously didn't like that. I wonder how the burn mark came here. There are no components here or on the bottom side. There just is right here, where the miscoloration goes around. Or maybe it's the MOSFETs here. But the border line goes like right here, so nothing with these MOSFETs to do. So here's the bottom side of the burn mark. The burn mark is right here, and this is the miscoloration. Thanks for watching.